I have both equations here. First, what I want to do is just go over some of the basics about positives and negatives. Let's see if we can figure this out. What is always positive no matter what kind of a lens is used? What variable is always positive?
DO.
Good,
the distance
DO.
of the object.
And what else?
HO.
Good, DO and HO. And I'm going to post this, so don't feel like you have to write anything down so you guys can follow along. DO and HO. What is positive if the image is real? What will tell us this is not a worksheet, Stephanie, this is just review. What tells us if the image is real?
DI.
DI, very good, DI. Sorry, hold on a second, DI, okay. What is negative if the image is virtual?
DI.
DI, good. The focal length is blank for a converging lens.
Positive.
Good. The focal length is blank for a diverging lens.
Negative.
Negative, good. Blank and blank heights are positive when measured from the principal axis and negative when measured downward. Blank and something heights. What two things are positive if they're upward and negative if they're downward or inverted?
M and HI.
HI, so the image height, and something else.
M.
Good, magnification. That's too big. Magnification, okay. Blank is positive for an upright image and negative for an inverted image. It's kind of just good. HI and M again. This is just both of these as symbols. Positive if upright, negative if inverted. Okay, hopefully we're looking at our notes. We've got all of that. And now we're going to practice these formulas. Two quick ones. So just grab your calculator and just watch what I'm doing. I'm going to post this. A converging lens has a focal length of 14 centimeters. A candle is located 32 centimeters from the lens. Where will the image be located? What is the 14?
Focal length.
Focal length.
Good. Is it a positive or a negative?
Positive.
Very good, because it's converging lens. A candle is located 32 centimeters from the lens. What's the 32?
DO.
Good. And do we have to change the sign of DO?
No, it's always positive.
Good. DO is always positive. Very good. And what are we solving for?
DI.
DI, good. Distance of the image. All right, so what formula would we use? If I have F, I have DO, and I'm looking for DI. The thin lens equation or magnification?
Thin lens.
Very good, thin lens. So that 1 over F equals 1 over DI plus 1 over DO. So 1 over 14 equals, I don't know DI. And DO is 32. Who can walk us through the steps to solving this equation? Elsa, go ahead.
You'd have to do the 1 over DO, like you'd have to switch it to the other side.
Good. Okay, so what's that going to look like?
1 over 14 minus 1 over 32.
Very good.
And then equals 1 over DI.
Very good. 1 over 14. Switch the sign of the fraction that you're bringing over. So minus 1 over 32 equals 1 over DI. Okay. Who can take it from Elsa? What's next?
You would like minus the 1 over 14 and 1 over 32, and then you get 224 over 9. and then you.
Did you already,
switch
Kira,
it.
hold on one second. Did you already flip it?
Yeah. No. Wait. No. Oh wait. Yeah, I did. Sorry. I
Okay.
was looking at my paper.
Yeah. Okay. So first I got 9/224. Or what is that as a decimal? 0.0. Yeah. Good. Thank you, Kira. Okay. So you get 9/224 or 0.401785, so on and so forth. And Kira is reminding us that that is 1/di. So flip it upside down and do 224 divided by 9 to get our distance of our image. So what, di over 1. Kira, what'd you get for your di?
I got 24.89.
Very good. Anyone have questions on any of that process that your classmates just led us through here? Questions? What if this question asked me, is this a real or virtual image? How would I know?
Is it a real image because the DI is also positive?
Very good. This would be a real image. It doesn't ask me that in the question, but let's just try to make as many connections as we can. All right, any questions on that one? All right, a statue with a height of 15 centimeters is placed in front of a converging lens. An inverted image with a height of 38 centimeters is noticed on the other side of the lens. What is the magnification of the lens? Why is this 15?
The image height.
Kira, read it closely.
Object height.
Good. Okay, and do we need to change that to positive or negative, or what do we know about that?
Positive.
Good. HO is always positive. An inverted image with a height. Okay, what's this 38?
HI.
Okay, and what's the sign going to be here?
Negative.
How do we know it's negative?
Because it's inverted.
Good, it's inverted. All right, so that matters. And we're solving for magnification. Sorry, my board is really lagging again. Okay, so magnification obviously is the magnification formula. It tells me to use the magnification formula. What two parts am I using here? I have M, HIHO, DIDO. What two parts am I using? Very good, guys. That was a team effort there. So M equals HI over HO. So we like these kind of calculations. What is the magnification?
Negative 2.53.
Very good, negative 2.53. Sometimes I just put the times there so I know that I've included the unit. What does the negative tell me about the image?
It's inverted.
It's inverted, good. And the word question tells me it's inverted. And if you look at the numbers, was the image magnified bigger or smaller than the object?
Smaller.
The object is 15, the image is 38. So is the image bigger, smaller, or the same size as the object?
Bigger.
Bigger, good, because 38 is bigger than 15. The negative just means it's upside down. All right, questions on this one?
This isn't a question for this one, but like, say you do another question and it has like centimeters. If you don't add it, do you get marks off?
Kira, because it's going to be a multiple choice test, I will already have the units there. Your options will all be there with centimeters or meters or whatever it is. So you don't even have to worry about it. For, sorry, go ahead.
For the test or for the exam?
Both of them, because they're both just going to be online evaluations.
So it's just going to be multiple choice. We just have to like figure out which one it is, right?
Yeah, yeah. But Nora, there will be a component where I will ask you to upload just a copy of your work so that if you do pick the incorrect answer, I can still at least see what the work was that you did. So you'll have the multiple choice questions, and then on Wednesday of next week, I'll also have a submit button. We'll just take a picture of your work, your actual solutions. It is part of your mark, okay? All right. The next thing we're going to be doing is getting into what happens to the light as it travels through your optical densities. So whether that is the window pane of your house, or when it's light coming from outer space into our atmosphere, if it's light traveling through the lenses of your glasses frame, what happens to light to cause it to refract? So what is causing it to make the light bend toward the focal point? Okay, it's the refraction. It's the speed of light changing in your different optical densities, okay? So with your speed of light, Sophia, yes, what's your question?
Will there be a conversation component to the optics test?
No, there will not be. Because it's mainly a math-based type of evaluation, like physics is the application of math in everyday life. That's why I want you to submit your work so I can see what you did. Okay, so here is the equation for speed of light. N stands for the optical density. So I give it to you. It's known. Scientists actually calculate the density of the different objects that light can travel through. There's a table here. It gives you all of the optical densities that we'll be working with. CV stands for speed of light in a vacuum. So that means the speed of light, not vacuum cleaner, vacuum like outer space where there is nothing to slow it down. So the sunlight from sun until it hits the Earth's atmosphere is traveling at 3 times 10 to the power of 8 meters per second. But when it hits the optical density, it slows it down. So Cn is the speed of light in that medium. So see how there's N and N? C stands for the speed of light, N stands for in that medium. So in the window or in water, or if you shone light through an ice cube, how much does the speed of light slow down? One thing I need to mention to you guys, because not all of us have experience with scientific notation. This number here, 3 times 10 to the power of 8, means I need to take the number 3 and move the decimal point behind it 8 spaces to the right. So 1, 3, 4, 5, 6, 7, 8. I'm just going to fill these in with zeros. So this is, let me put in commas so we can read this easier. 300 million meters per second is what this number actually means. 300 million meters per second. Now it's rounded, it's 2.997 something, or 299 million meters, but they round it to 3 just so it'll be easier to work with. We're going to be working with this as scientific notation here. So keep it as 3. And I'm going to show you on your calculators, or we're going to work on how to put this in your calculators. Yeah, because I'm just trying to think. I was like, is it easier because we're not in person? No, we're going to have to leave it as 10 times 10 to the power of 8 meters per second. If we have to change it to 300 million, we'll figure that out. Okay, so in this question, it says, a ray of light is traveling from air into water. So let's say it's going from air into a lake or air into your pool. We want to figure out what's the final velocity of the light in the water. Okay, I'm not worrying about what it came from, just where it is in the question where it's asking me for the speed in that medium. So I don't care where it came from, just what's the speed in the water. The way that you do this is you're going to figure out what information is given to you and what information are you solving for. N stands for the optical density. What's the optical density of water?
.333.
Very good. 1.333. And AG just looked over here at this table, right here, water. CV never changes. So I always have that number. It's 3 times 10 to the power of 8, 10 to the power of 8 meters per second. And I'm solving for CN. What's the speed of light in the water? I'm just going to plug those numbers in. N is 1.333. CV is 3 times 10 to the power of 8. And I'm solving for CN. This becomes algebra. How do I isolate for CN? Elsa, 3.3 times 10 to the power of 8 is the speed of light. It's right here. It never changes. CV never changes. Melody.
I don't know if I'm right, but because the 1.333 is technically over 1, could you just like cross multiply and then divide?
Yes, you can cross multiply. Yeah, so I can multiply the CN out of the denominator here. It's a little bit of rearranging when you got to find what's in the denominator. So then I have CN times 1.333 equals 3 times 10 to the power of 8. But then I have to divide off the 1.33. This is where it's going to get tricky. We got to figure out how to do this on our calculators. CN equals 3 times 10 to the power of 8 divided by 1.333. Okay, you guys are going to want your calculators because we have to figure this out together. Stephanie, you can do this without cross multiplying. Let me go over that here in a second. Okay, so if I would use my fraction button, if you have the box over the box button, and on mine, I can just do 3 times 10 with my exponent button, do to the power of 8 over 1.333. I'm actually going to put the answer down so that you guys know what you're looking for. And then we can make sure that we're all getting the same thing. CN, I'm getting this. Or some of your calculators may be giving you, these are going to be the same thing. This.
When we put it over 1.333, are we supposed to use the fraction button or the?
You can actually, probably if you don't have a calculator like mine with the box over the box, I would just use division.
What did you have? ABC.
I would not use ABC. It is not a complex enough button on your calculator to do all of this on your calculator.
Mr. Reed, I'm confused on like what I'm supposed to be doing on my calculator for this.
Okay, what kind of calculator do you have, Lila?
I don't know. Like it's a scientific one, but like I don't know exactly what.
Okay, so I would just do, and actually guys, to make this easier, I'm just thinking, let's change the 3 times 10 to the power of 8 just to 300 million. Because I'm not there to show you how to do this on your calculator. So let's just make this easier. Lila, do 300 million divided by 1.33.
Okay. What are you supposed to be looking for? The 2250.
Yes.
Okay, that's what I got.
Awesome. Okay, I'm gonna make sure that all of mine are not written in scientific notation. Guys, use 300 million as your speed of light. So do it like that because we're gonna have issues with our calculators, I think. Anyone not get the number that I have?
2.417.
What is that number, Nora? What does that stand for?
Is that that's like for the N, the optical density.
Good. That's N. Do you guys want to do this like a formula triangle or do you want to do this with the algebra rearranging?
Rearranging.
Sorry, say that one more time. I think two people said at the same time.
Rearranging.
Oh, rearranging. Okay. And somebody in the chat said they want to do it by the formula triangle. If you're comfortable, Stephanie, with the formula triangle, it is actually quite a bit faster. Otherwise, we can just do this by rearranging. So feel free to do either one. So N is 2.417. What is CV?
3 times 10 over 8.
Very good. So we're just going to write that as 300 million or 3 times 10 to the power of 8 if you're comfortable with your exponents. If we're doing this by algebra, then we're going to multiply Cn out of the denominator. Stephanie, if you've already used the formula triangle, you're going to be quite a bit faster than us. So just get your answer and then hold on 1 second. Equals 300 million. Now I have to divide off the 2.417. So on your calculators, you're doing 300 million divided by 2.417. What are you guys getting? Awesome, Kira. Anyone else get? Awesome stuff. Stephanie, very good. Sophia, okay. So it looks like some of us are pretty good. Okay, more of you guys are getting it. Awesome. Yeah, Melody, Karina, very good. Okay, so we're getting 124,120,810.9 meters per second. 124,120,8. Okay, good. Guys, look how significantly slower that is than the speed of light in water. So this is dramatically slowed down in a diamond. Why do you think that's the case?
It's like it's thicker or denser. I don't know how to explain it.
That's exactly right, Elsa. Diamonds are more dense. The particles are more tightly compact together, so the light slows down considerably. It's less than half of the initial speed of light in a vacuum. Half of 300 million would be 150 million, right? This is slower than that. It slowed it down a lot. And actually, diamond can even cause complete internal refraction, which means light, if you get it at the right angle, goes into the diamond and it doesn't escape out. It just keeps refracting around inside of it. It's kind of cool. So diamond is quite dense, so it slows it down quite a bit. So in this case, I have the speed of light traveling in the optical density, and I'm solving for n. So this is Cn, and I'm solving for n. If we're doing like this, like a formula triangle, what does this mean? What am I doing with CV and n?
Multiplying?
They're top and bottom. Top and bottom will mean division. So I'm going to have CV over CN. CV we know is always 300 million meters per second. And I'm going to make sure that when you guys have the evaluation, I give you the speed of light in the optical medium also this way. Or maybe I'll give you both ways. This number here, if you're good at putting in your exponents, try this. 2.206 times 10 to the power of 8. Otherwise, what that number is this number. 220,600,000 meters per second. So I'll make sure I give it to you both ways because I don't want your calculators to trip you up with this. So this is a quick division, CV divided by CN. Anyone get the optical density? You're going to want it as a decimal because that's going to be easiest for comparing.
I got 1.359927471.
Very good. So I'm going to round to. Go ahead, Kira.
How? I'm not sure, but it says 16 at the top, like in small numbers. So I don't know if that's like the power or something.
I think it's times 10 to the power of 16, because that's also what I got.
So I think the way you guys entered in your calculator, it added that final component. So it should actually cancel. So double, what kind of calculators are you guys using? So when we're solving for the speed of light, the optical density value, you're doing the speed of light divided by the speed in the optical density. So I'll write this out both ways in scientific notation, but also not in scientific notation. And you guys can figure out which one are you most comfortable with. So I have that, or it's also this, 300 million and 225 million. What's our optical density?
Water.
It's water? Is that what somebody said?
Yeah.
Good. It's 1.3 repeating. Doesn't matter which way you did it, you get 1.3 repeating. So that lines up with water.